Marusa,
Anjana, can you hear me?
yes, I can hear you. Who sir, Pratik sir connect?
नहीं, because I'm not. I don't know whether I think phone से भी disconnect हो गए हैं क्या? Because he's not
मेरे यहाँ
hearing
तो
me.
कॉन्फ्रेंसिंग दिखा रहा है.
Okay.
सब मुझे 2 मिनट और दे दो जब तक नहीं हो रही है कनेक्ट. ओके, आई एम ऑन अ कॉल. अगर कुछ भी होगा फोन पे हूँ भी.
Okay, ठीक है.
The person you are speaking with has put your call on hold. Please stay on the line. आप जिस व्यक्ति से बात कर रहे
मनोज सर, एक सेकंड. मनोज सर, आपको अब शेयर करना पड़ेगा बिकॉज आप ही होस्ट हो. या तो आप एक बार इनवाइट भी भेज दो और यूआरएल भी भेज दो.
Anjana, can you hear me?
मुझे वीडियो कॉल कर दो।
Anjana, Anjana, can you hear me? आपकी आवाज कट रही है। You are not audible. नहीं, उसमें बिल्कुल वो कट रहा है। उनका नंबर दे दीजिए अंजना, प्रतीक सर का। अंजना, कैन यू हियर मी?
So here we, in case of any issues. So we have some attack helicopters. It's for the limited war. It's used for the helicopters. And of course, there's a fighter planes and transportations. Here I focus more transportation of military aircrafts. So there are aircrafts which can transport military equipments, military personnel, and also the missiles, etc. But the fighter planes, which is also varying from the next generation planes and also stealth fighters, there's a different aspect. And the next one is the one areas which is currently developing in the last decades or so, drones and unmanned aerial vehicle. Plus also on Airbus we are already starting about air mobility, means we use as a kind of air taxi. So which is currently under prototype, which will be in the coming years to avoid some traffic. You probably, if you take the big cities, it's not limited to only India, but it's also in Europe, Paris or Frankfurt. If you take Germany, they have a lot of traffic. So there's a kind of potential solutions which is under exploitation by major aerospace players to think of air taxis. So I think the last category is drones, unmanned aerial vehicles, which is also will be used for the fighter planes. As you probably today you know, all the fighter airplanes is mostly manned by people. So there will be evolution on these areas where we will move towards unmanned fighter aircrafts. So this is where actually there's a big potential for the electronics engineers, electrical engineers, where we will develop a lot of radars, then missile guidance technologies, where there is a huge potential to be used for both the civil purpose. If it is a drones can be used for today it's primarily used for military, but there is also experiments in many countries where they want to use drones for the civil purpose to check weather climates, also to provide some information around for farmers, maybe some business industries, etc. So I think this slides you can imagine what is the full potential of aerospace. Of course, it's not spread across the different countries, but especially it's limited to a handful of countries today. As I said, Australia, Germany, France, Sweden, America, Korea, all these countries which is dominating this kind of all this wide range of aerospace activities. But India is also doing quite well, but not at advanced level as like advanced countries. So especially on the civil, we are not so far, but it's we have small aircrafts which is developed by NAL, which is located in Bangalore. So which is quite they are trying kind of smaller VIP planes. But of course, on the smaller aircrafts range of 200 seats, the wider body of 300 to 400 categories, and of course the bigger airplanes like A380, which is the largest aircraft, Airbus aircraft, which can carry almost 600 to 800 people, which is long range as well. Means it can travel from America to Australia. So I think on the civil aspect, India has to make a progress, but on space we are advanced. We are top 4 countries. But on the militaries, with indigenous the fighter aircraft which we developed, Tejas, I don't know if you have read the news. So a few weeks ago, this was cleared final operational status certificate to be used for the Indian Air Force. So this was the one aircraft which was indigenously developed in India. But we are not at the stealth aircraft like China and the US. But of course, this is the one area. But as you can imagine, there is a big step forward. So students like you, so you have a big opportunities to contribute to this aerospace. which is growing, not only limited to the government, which was the case till 2000s. Now there is opportunities in the private sectors for aerospace, and also there's global collaborations, not only within Asia, but there's also some joint projects between India, Russia, then India, Europe, India, US. So there's a big potential for the upcoming for the different fields as well. So I think if you are interested, you can just go to this website. You can just get some more details about aerospace history and maybe different aspects. So this is the website. It's from US. It's called the American Institute for Astronauts and Aerophysics. So this is something aeronautics and astronauts. So this is a really good kind of collection of all the evolutions done in the aerospace and also the future articles you can read through on this website. I don't know if you have some questions. Like if you have questions, maybe you can note down. Not to forget. Maybe of course we will have a last 15 minutes or so to take your questions, which if I could answer, I will do that. If not, I will try to get some answer as well. Okay, the next slide, this is more interesting for you, at least to understand what kind of contribution the core engineering fields which makes to aerospace. So I just try to categorize with the different fields and also the potential or the major tasks or the major activities involved with this field. Of course, this is not exhaustive. As I said in the first line, you can see the aerospace field has the highest ratio of engineers. So what it means, aerospace industry has more number of engineers ratio compared to the total employees. Unlike auto industries or other industries like maybe telecom or whatever the industries you can take. So in aerospace, the engineers are more because it's quite diverse, and I've not mentioned here the core field, mathematics, chemistry, physics, which is heavily involved, but it's coming under astrophysics or I would say that aero and astro categories. But I just put one major important aspects of the core engineering contribution in aerospace. So I will come to the picture which I can explain where you can understand the complexity of aerospace. But of course, first I will focus on the leftmost. So I take the mechanical, electrical materials. So of course, this is the core engineering fields which contributes for the different major tasks. So you probably wonder what mechanical engineers will do in aerospace, because you think that aerospace engineering should be must, but I think it's the contrary. So if you take any aerospace, either you take Boeing or Airbus or the Bombardier Canadian or Embraer Brazil, and also the upcoming Chinese and Russians. So this is not limited to only Airbus, but this is the nature of aerospace where you need different skills because you are flying in the space, where you will have some chemical reaction to the materials what we use on aeroplanes. So where we need chemistry people who can contribute to that. Of course, we need a physics is heavily used because there's a gravity. There is different temperatures, different the altitude. There's a different aspects. For the physics is the core field of, I would say, aerospace. So when it comes to the mechanical, electrical materials, as you can see, system design. So this is the one major classification where we have electrical system, mechanical systems, hydraulics, composites. So electrical, just to give. If you just remove the cabin in the aircraft, you can see full of wire in the structures. So what it makes this wire? So this wire is to carry the power required for the engines, jet engines, and also the power required for the cabins or in globally for all the power systems. And then there's the mechanical systems. What is the mechanical systems here? It could be wings, it could be landing gears, it could be the engines which is fitted, and also it could be the fuselage. So of course the aircraft, it might look one, but it's divided into the different fuselage. There is a cockpit or the nose, which is called nose fuselage, the center fuselage, there's a rear fuselage. Then hydraulics. Hydraulics, you can imagine, hydraulics is more to do with any suspensions which is used when you land. You don't feel like, you know, just landing hard landing. So there's a kind of hydraulics used as well. Then also hydraulics is not in the pure sense of suspension, including all the tubes. It could be wastewater tubes, it could be the tubes to carry the high power electricity in the aircraft. All is made of what we call hydraulics. So the composites, as you can imagine, the aircraft is made, the recent aircrafts, both Airbus and Boeing, is made of more of composite materials. So if you take the A350, which I was one of the first founder of this aircraft in a way for the design aspect. So we used 70% of the materials composite. Of course, there's a titanium, there's aluminum materials as well, but the composite is the major one. So it's for also for the weight reduction of the aircraft, and the full weight of A350 is made of composite. So then structures. So here the mechanical core skill is involved. You have to design an aircraft using airframe structures. So which is you need to do a lot of stress analysis to be able to say that okay, this structures will withstand any damage in space. It could be due to the natural issues, it could be some cyclone, it could be some volcanoes or whatever you could imagine. So this structure has to be designed by mechanical engineers in a way that it withstands all the possible use case in aerospace, in airspace. Of course, thermal fluid dynamics. So this is also the art of mechanical, where we use heavily, primarily not only for the fluid or liquid, but mostly gases. So you can imagine what is a gas, because you might know that airspace is more gas than kind of fluid. So here we use these principles of thermal and fluid dynamics to assess what could be the impact on the aircraft when it goes to certain level of temperatures. It could be very hot, it could be very cold, it could be very high altitude where there's not much oxygen, etc. So all this is contributed by mechanical engineers to assess. Then aerodynamics, you possibly know, this is the one of the foundation for any aerospace. So what it means, aerodynamics is more focusing on handling the kind of speed, takeoff, than maneuvers. So when you turn the flights or is there any emergency, aerodynamics plays very important role to stabilize the aircraft. Of course, currently in the new aircrafts, we have mostly the automated computer systems which can take full control of aircraft if any issues. This is to avoid the pilot manual errors. So of course the new aircraft, which is if you take the Boeing Dreamliner 787 or Airbus A350 or A330, which is fully controlled by what we call onboard computer systems, means in case of any emergency in the sky or landing or above the water, so we have full onboard computer system which will take the control and it will stabilize the aircraft and then hand over the control to the human. So you can imagine major work of computer aspect and electronics was contributed for this evolution of these technologies. And then propulsion. Propulsion is on the jet engines. So this is one of the core mechanical field as well, where the mechanical engineers design the engines, They contribute for the manufacturing of the engines. Of course, they are also maintenance of these engines as well, done by mechanical and electrical electronics engineers. Then stress and simulation. This is the one areas where you need to check aircraft for all the possible damages. You might see that even small bird hitting the aircraft, which could damage the structures. So the mechanical engineers who is specialized on the stress and simulation toolset not only does during the test time, even the aircraft in service. So what it means, assume that in Calcutta airport there is a aircraft which is damaged with bird hit, then immediately the engineers from Airbus or Boeing, whichever aircraft manufacturer of the aircraft, they assess the structural impact, whether it's good to fly or to ground the aircraft. So what we call on-ground aircraft. So in this case, the stress and simulation is part of full life cycle of aircraft, which is ranging from 40 to 50 years. So that's why you can imagine the process involved to certify the aircraft has to be the life cycle of 30 to 40 years, or some aircraft is up to 50 years. So whatever we develop, it has to fly for the 40 years, and then it should withstand all the climates and all the unforeseen issues in the space. And then of course, you know, all the emergency in case if something which we are not able to control. Then the next core fields, electronics and computer IT. So this is the one of the areas which is rapidly increasing in the last few decades, maybe last 20 years. So why? So guidance and control. So this is the one where, of course, we use what I mentioned, that in case of any uncontrollable situation in airspace, the onboard computer system takes control and guides and stabilizes the aircraft and leaves the control to the pilots. But this guidance and controls used in military aircraft heavily. So you probably know the Pulwama attack. So the one of the strengths was our missiles was exactly guided and mapped to the positioning of the locations. So here there is a lot of potential for the electronics engineers to design a kind of guided missiles or guided aeroplanes, or in the space. Space is heavily used. Space, you possibly would have seen the launch of the any satellites or possibly the shuttles. It follows certain directions. So the electronics on board on the shuttle or the aeroplanes or the fighter aircraft, which is guiding and helping to meet the targets. This is one major area where the electronics engineers, they use more embedded systems, including the software part as well. What you see in the pilot, the cockpit, the front of the aircraft, where we have almost 6 or 7 systems for the different aspect, where what we call, it's called cockpit systems, which is developed by using electronics embedded softwares. Then of course there's the radars and electronics in aircraft. So you possibly know this flight. I don't know if you see my cursor. So these are the flight actuators. This is primarily everywhere there's a sensor in the aircraft. So this is to get signal from on the path to the aircraft, whichever aircraft, fighter or military or whichever. So it gives continuously connecting to the nearest aerospace and gives some information about the plane and the puffers, and also it is also checks the radar checks the kind of temperatures outside and maybe icing. In Europe, it is very common issues in the winter. So that when you ground the aircraft in airport, in 12 hours, the full aircraft will be iced. So what is the impact? So the impact is you cannot fly. without kind of de-icing them. And of course, the sensor as well plays when you are on the top of the airspace. So here the temperature will be very cold during the winter in Europe. So the sensor, radars and electronics on board computer system is well integrated to receive the signals for the use of the pilots as well as for different performance of the aircraft as well. So every aircraft in Airbus is connected to our systems. So wherever it flies, it sends some information, but we are more interested on the performance of the aircraft. So what it means, so how it was flying, was it all the parameter was correct, was it the performance was as intended, or is it the efficiency of the aircraft is can be measured. This is our interest. Of course, there's the FCS flight control system. What I mentioned that it's more of controlling the aircraft. Then there's a lot of computer programming. It's mainly for the entertainment systems. There's for avionics. There is almost all the systems is controlled by computer, onboard computer. Then of course in the laboratory experiments like probes, in the outer space. So this is where you contribute electronics computer to image processing to get some more details or maybe more findings and process this information and send to the centers, the control centers. Then there's also multidisciplinary as well. Means here you cannot do only one with field. So for instance, automation, robotics, there's IoT, there's one extra I, sorry for the mistake. So it's Internet of Things. So where Airbus currently, since last few years, we are heavily focusing on this aspect to automate the design. So today the design is done by mechanical engineers, electrical engineers, electronics engineers, depending on the different components of the aircraft. But of course, here we are trying to more automate the design of the aircraft itself using the parametric approach. Then there is the manufacturing operations. So the as you can imagine, car assembly is very easy. It's a fully automated. But aircraft assembly is still a lot of like manual aspect. Maybe Mr. Manoj can confirm. He was visiting Airbus last time, a few weeks ago. So there was heavy activities involved, the manual operations, including the tracking of parts and the resource used for the assemblies. There's a big potential on this. What I'm talking is manufacturing solutions. It could be to simplify the worker instructions to assemble aircraft, or it could be to simplify the scheduling and planning aspect of resources, not resources in the pure sense of human, but even the material resources used for the assemblies as well. Then of course there's a maintenance and support which we are trying to automate and provide as a service to the airlines. Then the last part is maintenance and repair operation. This is for the aircraft which it involves in the service. So it could be some parts could be damaged, some parts has to be retrofitted for the regulations. So as I said, aircraft is developed for 40 years or 50 years. So you can imagine tomorrow if they ban specific use of the plastic in the aircraft, then we need to replace them all the aircrafts in service. So this maintenance and repair operations is mainly focusing on this aspect. So each and every aircraft is certified. It does not matter whether you have standard certification, but each and every aircraft is unique. Why? We could have specific cabins, means number of seats. If you take Emirates or Jet Airways, or they have more space, means they create more space between the seats. So this has a different configuration. So that's why the configuration of aircraft is millions of parts. So here we have a huge demand for IT tool sets. So any tool sets coming in the market, it's not fulfilling our aerospace use case, because we need to load the complete aircraft in the systems, computer aided CAD systems, or maybe the PDM, PLM systems, which I am part of design and methods and the process. So here we have some limited. So there's a big potential for the startups. as young students, you probably think some areas where you can start. So you can potentially explore these areas where you can focus on some tools to develop or to automate some manufacturing or the design, but the complexity comes with the use case involved. So you can imagine A380, it was almost 10 million parts of aircraft parts. So to load digitally and mock-up and simulate, you need a tool which is capable of loading some terabytes of data in the systems. So I think here even the Google and also the major Microsoft, we have some collaborations. So of course they come up with some basic products and then they use aerospace industry as a kind of laboratory to be able to mature the products. So we use Google Lens and of course the micro HoloLens, all aspects we are using in the menu. But I think this is one of the big potential for the people or the students who are thinking of startups. I think you would have got some sense. I don't know, it's just flavor, but it's not exhaustive as well. So you have almost all fields. Mathematics, physics, chemistry I kept out, but it's more focusing on the core engineering fields. But you can imagine the volume of activities done by each engineers, either computer, electronics, mechanical, electricals, or materials engineers as well. So now you can see maybe I will just focus on this aircraft just to explain. So of course, this is linked to what you can do as electronics graduates. So you can see the avionics sensor, aircraft conditions, monitoring systems, all is in this nose. So this is where a lot of electronics activities done. Of course, there's a cockpit control system, panels, display, everything. I would say this up to the entry of the the entrance of the aircraft. It's what the pilot says. It's full of made of electronics, radar, satellites, etc. Then you have some gullies equipments. It's where the mechanical engineers contribute, especially to design a kind of the trolleys and the equipments related to the meal serving and also the meal storage areas, etc. Of course, landing gears, braking. This is purely kind of hydraulics involved, mechanical involved, electrical involved. There's it's kind of multi-disciplinary scope as well. Then there is the exterior lighting, but the exterior lighting is very few. But if you just remove the cabin, if you see the aircraft, the wiring, what we call harness definition and insulation, which spreads to millions of kilometers, you cannot imagine. So where you need two kind of people designing this wires or the harness, and also the assembly this based on the power of the cable and the switches, etc. This is more electrical engineers which they contribute in the manufacturing part as well. Then you have jet engines. This is more of mechanical propulsion and also where of thermodynamics, and of course the flight actuators and the cabins. It's more of seating, materials, composites, all used. The different material used in cabin. So it's used for the interior decorations as well as for some seating aspect. Then of course the APU. I think this is a term which auxiliary power unit in electronics. People you should know as a students. So this is a small kind of engine fitted in the the rear. This is to power not for engine but to other systems. So it is more for cabins. So here this aspect is more involved with the power systems of electrical people and also the electronics people, of course the mechanical people, because it's also there's a mechanical properties of this power generation as well. Then you have oxygen systems, then power and data wiring. The power and data wiring is fully electrical. So you do a lot of wirings and different bundle segments which you will do that. And then there's the fuel, anti-icing, de-icing. As you can see, it's more of based on the sensor which feeds the onboard computer systems. Then pilot can control de-icing or anti-icing, and also our system on board can take automatic control as well. So I think exit slide. So it's nothing to it's more of in case of C. If you try to land in C, which is then we have this use as well. So maybe just we are running out of bit of time. Maybe I will try to just speed up a bit to have some time for questions and answers. So I didn't elaborate all, but these are the major opportunities in aerospace for different profiles. So you can imagine for aerophysicists. So this is more involving astrophysics and also aerophysics as well. Then you have aerodynamics experts who can propose the aircraft which is balanced, gravity is focused, ground on force as well ensured. Then there's a requirement specialist. So why it is important? You might think that it's kind of requirement specialist, what kind of role? But in aerospace industries, it's heavily regulated industry. It's if you take civil, military, or space, what it means, we cannot play in space because we don't have any alternate option to to have a kind of plan B. So in aerospace, we do always like this. Then the first requirements for any kind of requirements, engine development, aircraft development, or maybe the cabin or whatever. And then we go for the design phase. Then we manufacture and then we deliver and then maintain. So it means no aircraft or no aerospace will be done without requirements. So here the requirements could be the functional technical requirements, it could be regulatory requirements. Means it is you cannot fly satellites or any fighter aircrafts or military civil aircrafts without the certification of the American authorities called FAA. Then the European ESA. There are two certification authorities which will qualify for the airworthiness of the aircraft. So all start with the requirements. So we have a big scope for the requirement specialist who can analyze the requirements coming for the physics, who can analyze the requirements coming for the physical aircraft, who can assess the requirements for the functional parameters. Functional means it's more of assessing what could be the aircraft behavior in the high altitude. Here we don't have the physical aircraft to simulate, but we need to simulate in the based on the requirements on the systems or design tool set. Then of course the purchaser is who has a kind of a supply chain background, or the MBA graduates can contribute for this. There's a heavy project management activities. You can imagine the project management is very complex in aerospace because you are dealing with some big work packages with supply chain involved, and also it's on time, on cost, on quality. This is very important aspect which we focus on the project management. So here you can be a kind of management graduates, or it could be some technical project management because there are more technical project management as well in aerospace. Then chief engineer. Chief engineer is maybe it's a role which you have it only when you gain some experience. But of course, he is the one who drafts the aircraft on the paper and designs the aircraft and also tests the aircraft and do the delivery to the customers. Then in the recent years, with the computer revolution, there's a security threats everywhere. So in Airbus, it's very quite common. Every day, there's some people are trying to do. Maybe to just get some more information from the weakness of the solutions on the computer systems, etc. So here we are heavily focusing on this one. Here it's a skill is we are not expecting some pure kind of IT computer skills, but those guys who are good at hacking, maybe to just anti-hacking, all these aspects which we focus as well. Then UX designer is not just for web-based solutions, but we have kind of thick clients where the design tool sets users should have some good Unix, the user experience as well, means the GUI, etc. System engineer to check the systems, simulation engineers to assess the simulation. There's a manufacturing engineers who contributes on the assembly of the aircrafts. Then of course shop floor experts is to check whether this aircraft is assembled in a good conditions, the process followed, etc. Then business analytics. So as you can imagine, this is more about the big data, all these big buzzwords currently in the IT industries, where we focus as well, because we are one of the biggest generator of the data. Means for various aspects, we produce aircraft for the data for the performance aspect. We have a lot of design data. We have other non-structured data, etc. Here we have a big potentials for the new aspect which is coming here. Data analyst or scientist. Even we have a scope for the pilots. So the pilots is the one. Of course, there is a risk involved. Is checking the the new aircrafts, etc. Then there's a lot of architecture roles, because we focus heavily on the architecture of the solutions, especially on the systems, IT systems, electronic systems, electrical systems. It could be the mechanical system as well. So there is a different aspect of architects. There's a system level to ensure that system is working. Solution architect is more focusing on the big areas. Then there's a technology specialist. Could be CAD tools. It could be some IT tools. It could be communication tools. It could be platform access tools, etc. And of course, we are one of the biggest infrastructure users of what we call the cloud, the big data. We have our own cloud, so we don't rely on the Amazon or maybe others, because for a security aspect. But we have a built huge kind of private cloud solutions in Airbus. But I'm talking about this more in other aerospace industry as well. So you can, of course, system designer. Here the mechanical designers, they involve the design of aircraft. So you have electrical designer, there's a mechanical designer, there's composite designer, there's a material designer. Then contracting aspect as well. So we deal with contracts. So there is a scope for the contracting aspect as well. Then finance people, human resource. This is kind of more of shared people. And then of course we do as well business management as a one areas, where we more focus on handling the customers' feedbacks and the stakeholders management, etc. So I think, as I said in the beginning, these are the major roles which you see in aerospace, but not limited to only these roles. You have much more mathematicians, physics experts, chemistry experts. I think you can imagine the aerospace is most diverse industries in the world, I would say. Yeah. So I think that's the end of my slides. I didn't make, as I said, I didn't make more slides, just to keep you, the focus on only the important things for now. Of course, there's it's not one day. We are governed by 232 business processes for various aspects, starting from the concept, design, manufacturing, and the support of the aircraft. So I think that's my, the slides on your areas. Of course, concluding remarks. So this is to give some information about what you can expect. I'm talking about 2050, this range. I'm not now. Aerospace, it takes a bit longer time than other industries to evolve technologies, etc. So what I see, I try to summarize in concluding remarks. Of course, aerospace has a future. Because for a simple reason, even in India, you might have seen, air travel has become kind of real, common man, the kind of mode of transportation. So there are two drivers: regional connectivities, means like India is quite a vast country. You can have between regions. Of course, South Asia. I'm talking about the regions in the continents as well. As a global world. And of course, the growth potential for the passenger air traffic is estimated 20 to 30% in the coming 30 years. So we have, I think, the commercial aerospace as a big future. So what it means, more aircraft has to be produced, more engineers will be working on this design, manufacturing, automation of this aircraft. So here you have a big potential for the automation aspect. Then when it comes to the military, which I see, military aerospace will go global. What I mean, today the military is limited to each country, but the affordability and the future technology cannot be built by one country. So it could be kind of continental, like Europe is France, Germany. They're already starting the fighter aircraft new generation. So means it will come out of kind of silos. It will move towards kind of global. Then military aerospace also goes autonomous. What it means, autonomous not in the pure sense of power, but here it's more without pilot. Means it will be kind of automatically unmanned the aircrafts which will do this whatever the task it's intended for. And then civil aircraft goes greener, which I am part of the research and technology on the electrical aircraft. So of course we are at the early stage. We have some limitation on the technology available for the power storage, etc. But in the next 30 years or so, there will be aircraft which is greener, not using traditional fuels, but it's more of powers generated by renewable energies. But last one on the space sector, it's more focused on the cheaper, because today's space is very niche, and also sending satellites and also sending the humans to the space is not millions, but it takes a lot of money. So, and also the access to the space is very limited today. So in next 30 years or so I see that it's going to be cheaper. As you probably know, in America there's a SpaceX company, which is a fully private owned, possibly the first private space companies in the world. Of course, now the Amazon and other companies also, they are getting into this privatization of the space industries as well. So here there's a big potential for cheaper and easy access. Even you can go for tourism to the space. So this is what I see as the next 30 years or so. I think that's globally my concluding remarks, especially to think or to maybe to give or to ignite you to think aerospace as a real career opportunities when you come out of whichever field. But of course, you need to have some practical skills. So this is where I appreciate Mr. Manoj as well as your college administration to embed the applied learning on the curriculums of it's more of a theoretical nature. So I think these kind of things is needed for aerospace industries to start with. Of course, we don't expect 100% match for each job. We expect at least 50% of match. So what it means 50%, you need to have some practical skills. You need to, whichever the field you are contributing. So I think the initiatives which I see as a positive to bring industry closer to the academics and of course give the opportunity for the students to see how the theoretical knowledge what they gain from college or through professors can be applied on the real industries with you cannot develop aircraft for sure, but at least you can think of developing or prototyping smaller part of different aspects. It could be sensor, it could be some tools for automation, it could be for the design tools, or you can imagine whichever areas what I have exposed. Yeah, I think that's more of end of my slides. But now I would be happy to take your questions and try to answer as much as possible.
Thank you so much. Thank you so much, Anbu. It was definitely very informative. I'm sure that the students would have enjoyed because we need to know what all the keys we have. Then only we can explore further. So, Pratik sir. So we can have a Q&A session for I think 10 minutes. So if a student they have, you can bring mics to them.
Good afternoon, sir. So my question is, do we need course after engineering to join admission?
I'm sorry to interrupt. I could not hear. Maybe if you can just speak louder or close to mic, it will help me.
So do we need to do any specialized course after engineering to join admission industry?
Not so bad, not so good. Maybe I don't know if someone can translate maybe later. I think it should be fine. Or
Sir, can you? It's of course even we cannot hear.
The students are curious to know that do they need to pursue any course to get into the admission after the graduation?
I tried to catch, your partial question. I think it's more of critics. I could not understand fully, but if you can.
Who does students need to go to the courses for joining the aviation or aerospace after the graduation?
I'm sorry to again say that it's quite difficult. If someone can use this web, there's a chat as well in the WebEx. So can you type your questions like on this one if you have someone computer? That would be faster.
Pratik sir, there is an option to chat. Can you post your question?
I think that's not a good efficient way, but at least this could be better because otherwise I could not hear you properly. Yeah?
So question and
yes.
So question they are asking. Did you see the question? I think he said.
I think you have to use everyone option because they might have sent to host. Yeah. Otherwise you can forward me. Otherwise, yeah, I will.
Yeah. I am forwarding.
Maybe to save some time, you can collect maybe a written question and just if they can small poster as well, so which we can take as well after this session as well. I don't know if you have such a facilities.
Yeah, Tanvu, I sent the question.
Yes. Okay, I think this what I try to understand, but of course this is really a good questions, and also one of the primary reason for this awareness session is to expose you this level. So of course in India as well and also Europe, we don't need any previous experience on the the kind of course to join either master on aerospace or even if you want to join a job. So what I'm trying to say is, assume that you are completing mechanical engineers, you can still apply for different roles in aerospace, but here we expect to have some practical skills of assume that mechanical, you probably know, you might hate as well, thermodynamics and also fluid dynamics. This aspect, if you come up with some practical, this will help for the job. But of course, but we don't have any prerequisite. The mechanicals can go to aerospace course, aviation industries, for job or for studies, or for that matter, electrical, electronics, even the computers can join as well. But of course, it depends as well the institute to institute, but there's no prerequisite as such for the job or the core for the after graduation if you want to study for it.
Thank you so much. And the next question is, what are the research going on to the super alloys?
Yes, I think that's really a very good questions, and also we are doing some research which I am part of it as well. I think today we use aluminum alloys and also titanium and composite, but now we are also doing some research project on the thermoplastic for the fuselage. Fuselage means it's the aircraft outer part, the structures. So of course on the Airbus we are doing as a kind of the concept phase now, where we are trying to simulate the different alloys on the fuselage areas, but this is going to be the new materials in the aircraft which will be launched in the next 4 or 5 years. So it's not only limited to Airbus, but I think all the aerospace industries, they are really working on this to find some not a traditional aluminum alloys, but see, this is something like, in the internship. I think this is one of the things is very strong point in Europe and the US. So if you take my company in Europe, France and Germany, so the internship is close to 7,000 students are there at any point of time. You can imagine. So of course we are a company of 130,000 people or 130,000 people employees, but 7,000 students at any point of time doing internship. So it's not necessarily from engineering graduate, the students. Also it starts from very early at the age of 14. So when it comes to India, it's very limited, what I would say. Of course there is HAL, there is NAL, there is some DRDO labs, Aeronautical Development Agency, Aeronautical Development, say the establishment which is developing engines, etc. I think what is today is they encourage some project if it is 6 months in this industries, but not for some shorter durations. But as such, the internship concept is very few in India, where I am trying to promote as well through Airbus India. So you probably know the Airbus India is located in Bangalore, where we have almost 400 engineers plus supply chain, where I'm trying to promote some kind of internship in this company. But to answer your questions, it's very limited today, and I would personally say that it's not encouraged in India so far. But whereas the aerospace powers located in Western countries, it's very common to have a large number of internship positions. This is part of the corporate social responsibility of the company as well.
Thank you so much, Anbu. Pratik sir, is there any other questions or we are good? So sir, if I heard correctly that we do not have more questions, right? Okay. Thank you so much. Thank you so much, Ms. Anbu, and thank you so much, Pratik sir and students.
Of course, thanks for today, and of course this is to just give some overview. So I hope it will make you to think or ignite in some to see as a potential in aerospace. Of course, if you have some questions, maybe I will share the private contacts, maybe to Mr. Manoj. You can just share with students if they have some any queries now or later. I could help. Yeah.
Sure. Thank you so much. Thank you so much for your valuable time, Anbu. Thank you, guys.
Then, yeah. Thanks a lot. Then maybe have a nice day. Yeah.
Bye.
Okay. Bye bye.
Bye.
Thank you guys for your kind cooperation. But one suggestion I am having for you, if you cannot run away from something, try to get into that. अगर आप बाहर से करते हो तो कोशिश करो कि क्या निकाल सकते हो और and it was clearly possible. अगर आप सोचने की समझने की कोशिश करते हो, but यहाँ तो सोचना क्या कॉम्प्लिकेटेड पर इसका काम करना है. पेशेंस रखने के लिए बहुत बहुत धन्यवाद आपका और नेक्स्ट टाइम से ऐसे टॉलरेट नहीं करेंगे. ठीक है. I'll make sure.
हेलो। हाँ। वो वहाँ नीचे तो आइकन आ रहा है अब रिकॉर्डिंग का, पहले ऊपर आ रहा था। अब वही मैं चेक कर रही थी। जस्ट कितनी साइट रिकॉर्डिंग स्टॉप हो गया।